What is integration testing? Hi all, my name is Kaushik Chowdhury. And what is the outcome of today's lecture? There are two things that we are going to cover. One is concept of integration testing, and the second one is the difference between unit and integration testing broadly. So integration testing assesses an app's components on a broader level than unit testing. And the main difference between integration testing and unit testing is that integration testing often includes applications infrastructure components such as database, file system, and these infrastructure components are used as mock or fake objects in unit testing. So we fake or mock these objects, database, file structures, networking, etc. But with integration testing, we want to ensure that the whole app is working as expected with all these components combined together. So the integration tests require more code and processing, and therefore they take longer to run. And they use the actual components that the app uses in production. Integration tests should be limited in their usage to the most important use case of infrastructure. If we could use either of the two types of tests, like the unit test and integration test, for testing a behavior, we should definitely go for the unit test for doing this, not the integration test. And ASP.NET Core supports integration tests using a unit test framework with a test web host and an in-memory test server. The application to be tested is commonly known as system under test, or SUT in short. So we'll be using the short form SUT henceforth to refer to system under test. And SUT can be any type such as Razor pages, MVC, or web API. And a NuGet package which is known as Microsoft.ASP.NET Core.MVC.testing is essential for integration testing. Now this package includes a web application factory class, and test web host and a test client are created that are part of the web applications factory class. The test project refers to the SUT project as its dependency. The Microsoft.ASP.NET Core.MVC.testing package has some functions. So the important three functions are: it copies the project dependencies or .deps of SUT project to the bin folder of the test project, and it sets the content root directory of the test project to the root directory to the root of the SUT project, so that the static images, files, and pages can be viewed as tests are executed. And it is used to bootstrap the test server with the SUT, or system under test. Now, before we embark into the all important steps of integration testing, it is good to discuss that the test project is included in the same solution, and which contains the SUT, or system under test, and this test project is used to contain and execute the integration tests, and it creates a test web host, and it uses the test server client to handle the request and responses with the SUT, and it contains the test runners to execute and report the test results. And in the steps for the integration testing, it follows the usual arrange, act, and assert workflow as in unit tests. And in the arrange step, the requests are set up. And so we'll see the steps, or the code snippets for each of these three steps. The requests are set up in the arrange step. So var client equals is assigned underscore factory.create client, as you can see over here. So client is a variable, and factory is a factory type instance web application factory, as we'll see in the next slide, and create client is a method that will create an HTTP client. So underscore factory is an instance of web applications factory with a T entry generic point, where the generic T entry is the entry point to the application, which is the program class. This factory object is dependency injected. Now in the ACT step, the client submits the request and receives a response. For example, in the ACT step, we get the response by awaiting on the client object and calling the getAsync method and passing the URL, which has been passed as a parameter to the action method. In the assert step, the assert steps are used to validate the response received against the expected response as pass or fail tests. For example, an assert will have the response object created in the ACT step and call the ensure success status code method to check whether the is success status code boolean returns true and status code is lying between 200 to 299 for its success status. And assert.equal is actually it is validating the response against an expected outcome with the true outcome, actual outcome that you have got. So this is the expected outcome text/html char set utf8 and the response.content.headers.content type.string should match this string for the test to pass. Okay. The results are finally reported by test runners. It is a good practice to use separate test projects for unit tests and integration tests, that is not to mix them in the same project. This ensures that they can be run independently of each other to allow control over which set of tests to run and to prevent the accidental mixing of infrastructure components in unit tests. Basically, the integration tests for Razor and MVC projects are written and configured the same way except in their naming convention. The Razor page tests for endpoints are named after page model class, that is index page tests to test the infrastructure components of index page, and for MVC the name of the tests are based on the controller class that they are intended to test the component integration, that is home controller tests, which indicate the test for home controller component integration. So in this lecture we have covered a lot of ground. We have seen the integration testing with ASP.NET Core with some salient points, and that the ASP.NET Core.mvc.testing NuGet package is absolutely important to include in the test project, which includes the web applications factory class and which is required to create a test web host and test server client. And we have seen the workflow of the arrange act assert steps for an integration integration test and seen the code snippets.